Okay, so as you recall from a previous discussion, we said we've got the universe, and from a chemist standpoint, we break the whole universe down into two things. We say everything is either a form of energy or everything is, wow, that's nice, isn't it? Yeah, I don't like that. Let's get rid of that. Or everything is matter. Good. And we said, okay, it's important for us to understand what matter is. We said that matter is anything that has mass and volume, meaning it takes up space and it has substance. So anything that has mass and volume is matter. Now today we want to come over here and further our discussion of matter, and we want to talk a little bit about the types of matter. Okay, so to do that, let us go to our favorite little consider idea. So consider a piece of copper, sodium chloride dissolved in water, a piece of copper in water, and three hydrogen atoms bonded to a nitrogen atom. And the question here is, which of these is a pure substance and which of these is a mixture? So we want to figure out a piece of copper, sodium chloride in water, a piece of copper in water, and then three hydrogen atoms bonded to nitrogen, and identify those as either a pure substance or a mixture. Okay, I think we have an idea of what we need to do. So, we're over here, we're talking about types of matter, and we know there are at least two types of matter from the question that we placed, right? We said one type of matter could be a mixture, or one classification of matter, and the other classification of matter, the other classification is pure substances. So that means matter can be broken down into either mixtures or pure substances. Good. So what will be helpful for us is if we can define these in some way. So what's a pure substance? A pure substance is matter with a fixed composition. Well, what does fixed composition mean? Well, fixed composition means that it has a relationship that is never changing. And I guess the best idea for me is let's think of water. Water is an example of a pure substance. H2O, what does that mean? Well, H2O means that I have one oxygen atom and I have, let's go with a different color, and I have two hydrogen atoms overlapping that oxygen atom. Now, can that ever be one oxygen atom with three hydrogens? Not if it's water. If I have H3O, that is no longer water. Yoink. For me to have water, I must always have the same composition. One oxygen and one oxygen and two hydrogens. It must have that fixed composition of one oxygen and two hydrogens for it to be water. So that's what we mean by matter with a fixed composition is a pure substance. Good, let me take this off. Oh, I just destroyed my composition. So we'll fix that up. Composition. Good. Matter with a fixed composition is a pure substance. Now, we have two types of pure substances. We have elements and we have compounds. And we'll get into those in a minute a little more, okay? Let's come over here and look at our mixtures. What's a good definition of a mixture? A mixture is a blend of matter in which each component maintains its identity. Okay? An example of this might be if we drop some sodium chloride in water. Sodium chloride will dissolve. And that makes a mixture. But my sodium and my chlorine both maintain their original properties. They are not transformed into anything else. And so this is what we would call a mixture. Sodium chloride in water is a mixture. And why is it? Because my sodium still is sodium and my chlorine still is chlorine. They are not transforming into other elements, other compounds. Okay? Good. So let's see if we can go back and answer our question based on this. I have a piece of copper. Now, do I think that's a pure substance or a mixture? Does a piece of copper always have the same composition? And the answer is, hey, piece of copper right here, does it always have the same fixed composition? Yes, it does. So a piece of copper is a pure substance. Sodium chloride dissolved in water. Oh, I just talked about that. I have sodium chloride. When it's dissolved in water, the water still stays water, and the sodium and the chlorine still stay sodium and chloride. And so sodium chloride in water is a mixture. Let's see, what's next? I have a piece of copper in water. Well, does that have a fixed composition is the question. Can I have one piece of copper in a little water, one piece of copper in a lot of water? And the answer there is no. It's not really a fixed composition because it's not like I'm saying I have one atom of copper that is attached to one molecule of water. Instead, I could have all kinds of water surrounding this copper. So in this case, copper in water is a mixture. 3 atoms of hydrogen bonded to a nitrogen atom. So that means I have something that looks, we call that ammonia, by the way. And I have a nitrogen, and on that nitrogen, I'd have 3 hydrogens, and they'd be bonded that way. And every time I have ammonia, it looks that way. And if it's not that way, then it's not ammonia. So that would be something that has a fixed composition. So I would put ammonia as one of my pure substances. All right. I know that's a little tough because we're just getting to the idea of chemistry, and sometimes it's hard to tell if something is a pure substance or a mixture, but I think you can have an idea. So let's give it a shot and see if you can do this on your own. Here we go. Consider 4 atoms of chlorine bonded to 1 atom of carbon. Next, consider 5 atoms of antimony. And finally, think about 2 grams of neon gas in a tube with 7 grams of helium. Which of these is a pure substance and which is a mixture? Okay, I'll give you about 30 seconds to figure this one out. Okay, so what do you think? 4 atoms of chlorine bonded to 1 atom of carbon. Well, that's a clue here. When we say bonded, what does that imply? That implies that I have carbon. Where's my carbon? So I'll have a carbon, and on that carbon, I will have attached 4 chlorines, right? Now, do we think that's going to be a fixed composition? Absolutely. This is going to be a fixed composition. If it's a fixed composition, that means it is a pure substance. So my chlorine bonded to carbon, that's a fixed substance. It's a pure substance. How about if I just have 5 atoms of antimony? Antimony is Sb, and I just have antimony. Good. Is antimony going to be a fixed composition? Yes, it is. Antimony is always antimony unless you change the number of protons. So it is a pure substance. What about if I just have some neon gas and some helium gas, and they're just floating around in a tube? Is that going to be a fixed composition? And the answer to this is no, it's not a fixed composition. And so this is a mixture. Okay, now I think like I say, there may still be some questions here about what a mixture is and what a pure substance is, but I think this will be clarified as we go further, excuse me. So let's move on. Let's go to the next consider. Consider water, copper, ammonia, and manganese. Which of these are elements and which of these are compounds? Okay, so let's go back here. We talked about pure substances, and we said that there are really 2 types of pure substances. There are elements and compounds. There may be more, but we want to focus on elements and compounds. And we need to then come up with a way of differentiating between these. And I guess the best way to think of it is, first of all, an element is a pure substance which cannot be broken down into a simpler, and this is important here, stable substance. A pure substance which cannot be broken down into a simpler, stable substance. And elements are things like sodium, copper, antimony. We've already talked about antimony. Strontium, how's that? Those are all elements. How is an element different from a compound? Well, a compound, first, is a pure substance which can be broken down into a simpler, stable substance. Good. Let's extend the page a little more. Simpler, stable substance. Not only that, when we think about a compound, really a compound is a case in which elements are bonded together chemically. That's a compound. And compounds are things like H2O, water, carbon tetrachloride, carbon dioxide. In these cases, I all have a couple elements which are somehow chemically bonded, chemically held together. And so that's really the difference between an element and a compound. So let's go back and take a look at our question. Which of these are elements, which are compounds? Water, H2O, do we think that this is an element or a compound? Hey, this is going to be what? Water is going to be a compound. Yoink. Compound, H2O. Good. How about copper? Element or compound? Copper is an element. Ammonia, NH3, what does that imply? That means I have a nitrogen, and on that nitrogen, bonded to that nitrogen are 3 hydrogens. If they're bonded, that's going to imply that what? This is a compound. And manganese by itself, that is going to be an element. Good. I think this is coming around. Let's see if you can handle this on your own. You have a strip of sodium, carbon dioxide, and carbon monoxide. Which of these are elements and which are compounds? 10 seconds for this. Okay, what do you say? Sodium. Well, sodium doesn't look like it's bonded to anything. Uh, can it be broken down into a simpler, stable substance? No, so that means sodium is an element. Good. Carbon dioxide. Can I break down carbon dioxide into carbon and to oxygen? Yes, I could. And so would that be a compound or a element? Well, CO2 then is a compound if it can be broken down into simpler, stable substance. Same thing. I could break carbon dioxide. I can break a couple carbon monoxides down to 2 carbons and O2. Those are both stable. And so carbon monoxide is also a compound. All right? Good. Questions so far? Well, let's move on. Let's see what our next consider is. There we go. I have sodium chloride completely dissolved in a water. I have a piece of copper undissolved at the bottom of a beaker of water, and I have the air in the room. Which of these are homogeneous mixtures and which are heterogeneous mixtures? Ay, ay, ay. We've got some new words here that I've not seen yet in our discussion. We have homogeneous and heterogeneous. I guess that means there are a couple types of mixtures. So let's go back to our beautiful picture here. Oh my gosh, look at that. And let us fill in some stuff here on our other side of mixtures. So we said a mixture is a blend of matter in which each component maintains its identity. And we said something like sodium chloride in water is a mixture. Okay, but there are 2 types of mixtures. We can have heterogeneous, and we can have homogeneous, Okay, heterogeneous and homogeneous. So let us define these 2, and then maybe that can help us understand how to answer the next question. Homogeneous mixture. Homogeneous mixture is a mixture with a uniform, not fixed, but uniform composition. What does that mean? Well, this means that every sample is identical. And I like to think of this as if I have this mixture in a glass, and I take a drink from the top and a drink from the bottom, I'd get the exact same thing. So let's say that we have some kind of a foofy coffee that you would buy over at Starbucks, and it's got foam at the top, right? Now, if I take a drink at the bottom, I get only bitter coffee. Ugh. If I take a drink at the top, I get foam. Well, is this a uniform composition? The answer is no, because at the bottom I have coffee, at the top I have foam. This is not a uniform composition, so this is not homogeneous. Well, if it's not homogeneous, what would it be? It turns out that it is heterogeneous. This is a mixture without a uniform composition. And so what would be an example of that? Like I said, oops, sorry about that. Something like, I don't know, a latte with whipped cream. Yeah, latte with whipped cream. And what would be a good example of a homogeneous mixture? How about the water? No, that's not a mixture. How about Let's see. How about just straight coffee? Coffee with no cream, no sugar, no foam, no whipped cream, a man's coffee. That would be a homogeneous mixture. Okay, so let's see if we can answer our question. Where is it? Are we here? No, we need to go on. Are we here? There we go. Sodium chloride completely dissolved in water. Okay. Remember, we want to determine does this have a uniform composition or a non-uniform composition? Well, sodium chloride completely dissolved in water. When I think of sodium chloride completely dissolved in water, I'd think, okay, I've got a glass here or a beaker. I've got some water in here, and then I've got some sodium chloride pretty much evenly spread out. There's not a pile sitting at the bottom. It's evenly spread out, so I would consider this a uniform composition. So I would say that sodium chloride in water, dissolved in water, is homogeneous. How about a piece of copper undissolved at the bottom of a beaker? Okay, so let's go with a different color here. Now I have another beaker. I've got some water in it, and I have a chunk of copper here at the bottom. Now, if I take a drink at the top and a drink at the bottom, do I get the same thing? No. If I get a drink at the top, I only get water. Drink at the bottom, I might swallow the copper. So that would indicate that this is not uniform. And if it's not uniform, that would mean it is a heterogeneous mixture. Copper in water is a heterogeneous mixture. And finally, the air in the room. Okay, think about the air in the room. This is a tough one. I would guess that in general, the air in the room is pretty evenly distributed. Now, one could argue that, hey, coming right out of my mouth, I have some carbon dioxide, right? So this is hard to interpret. It all depends on um, your view of this. So let's assume in this case that I am not in the room. No one's in the room. And so that means no one's producing any carbon dioxide. And so if that's the case, the air is going to be pretty much, I have some nitrogen and some argon, and I have some oxygen, and they're probably all floating around pretty evenly. And so I would say that this is going to be a uniform distribution. If it's a uniform distribution, that means my air is also a homogeneous mixture. Okay? And as you can see, there's some, it's not always a straightforward answer. It can be tough. Good. Here we go. Let's see what you think. You got Pepsi, pizza, and silver nitrate. Oh, let me rephrase it. You have some Pepsi, you have some pizza, and the third one is you have silver nitrate completely dissolved in water. Which of these are homogeneous mixtures and which are heterogeneous mixtures? Okay, I'll give you a few seconds to consider this. Okay, Pepsi. They just have some Pepsi. We'll put it in a beaker or glass so that we can maintain it. But if I have Pepsi, if I drink from the top and the bottom, we got some foamy stuff in there. We got some, that's Pepsi, right? If I drink from the top and the bottom, do I get the same thing? Yeah, I'd get the same stuff at the top and the bottom. So I would say that this is a homogeneous mixture. Pepsi is a homogeneous mixture. Good. What about pizza? Well, let's consider pizza. My favorite would be something like Hawaiian. So I have pizza, and there's a piece of ham, and then let's throw in, here's a pineapple, and pineapple, and some, well, not ham, Canadian bacon, Canadian bacon, Canadian bacon. Then I got some cheese on it, and I've got the crust. Now think about that. If you take a bite here, you get crust. You take a bite here, you get pineapple. So is that the same thing throughout? Is that a uniform composition? No, it's not a uniform composition. So that means pizza is a heterogeneous mixture. And finally, I have silver nitrate, completely dissolved in water. Hey, when we say it's completely dissolved, that means it's pretty evenly spread throughout, that I don't have a big blob at the bottom. And if it's completely spread throughout, that means it has a uniform composition, which means that silver nitrate is also, silver nitrate in water is also a homogeneous mixture. Okay, good. So I hope you understand those things. And next time we get together, let's talk a little bit about the properties of matter. Okay, thanks. See ya.